Hello, now we have opened safe interface. So now we are importing our loads data from ETFs. So our base loads, so we have already exported to safe file. Let me import that safe file into safe interface. Click at file and open import safe.f2k file. Just click here. So you need to go to your directory where you have already saved your uh, file. So I just click here .f2k file and open my file. So you need to set also your units because my ETF unit are metric. So you click here already metric. So just choose metric, and you want to check your metric or not. You can go and draw dimensions. From here to here you can draw your dimensions. So this is okay with my ETFs model also. So you can also get a DXF file from CAD also, but my model is already done in ETFs, so I have the grid data. So from that grid data, I already imported in save file. Let's go and display your loads. Just go load above, dead load. Let me check one of the loads. Live load above, RSDL above, live load above. Let me check this one, show load labels and display in 3. So this is your loads. You now need to make the load patterns and also load combinations to do the analysis for the footing design. Today our lesson is about how to design mat footing in SAFE using SAFE 2000. SAFE 2000 a very important tool to making shell element design like slab and footing and also mat footing design. So let me go to the plan XY here, and I want to draw some projection from this to outward and make one mat footing here. Before this doing, I need to go and define material. Let me define the material. So I will want to go quick define material. Now you know about how to define material because the interface of SAFE, ETAP and SAFE is almost same. So just I concrete and I use concrete this material, okay. And you can modify this material name by doing this is I call this C28 concrete, okay. All other units are as default and almost they are okay. So compressive strength you need to mention here 28 or 20. I put here 20 and I use this one as C20 concrete. This concrete design will be from your QA/QC section, and this will be given by your laboratory from mixed design, okay. This density you need to put the unit weight of concrete, and this is unit elasticity, modulus of elasticity. This is Poisson ratio. This is the thermal expansion. So this is you know about the each material is different holding these properties. Let me okay, and let me add quick material because I will use rebars also. Grade 60, okay. So let me modify the name and I call it G60, okay. So you also know the unit weight of steel, modulus of elasticity, and this is 413 Fy and okay. This is just okay. Now I have defined all these material. Let me define the mat slab properties because mat is a slab property. So I add new mat. So I call it a mat. So from here I will choose the slab material is C20 and color is okay. Slab I will use 200 initially. You can change this one. And From here you need to change the type. It's very necessary. It's very necessary. You need to change the type and it's called matte. Okay. 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 Our definitions almost done for the material and slab properties. Let we have one subgrade properties, because we now need to know the beneath soil properties, what type of soil there and what type of soil, uh, because normally in a settlement we have a allowable limit of settlement and we have the bearing capacity of that soil. So this is bearing capacity of this soil, and let me check what is the requirement of the soil one. You can add another property, but I will keep as it is and I just modify. So let's check whether what is the requirement of safe inputs. Here soil color, okay, no problem. Here is subgrade modulus. This is very necessary, that every type of material have different uh, soil properties and different modulus, subgrade modulus, or we will use as a compression only. Okay, because we are footing design, so compression only. So here is subgrade modulus. So subgrade modulus we have different, because we have different calculations for subgrade modulus. You need to check your how we find the subgrade modulus, because I don't want to this in this video, because you need to know the concepts by yourself. And I have already copied one modulus of subgrade direction. Let me open. So yes, these are visible. Humilis soil, peat soil, this is the modulus subgrade direction, kilonewton per meter square per meter. So recent embankments this have. So now well compacted sand this have. I consider this is a well compacted sand, and it's in between in between zero point 0.1 million to 1.5 million. I will use the middle one, so I will use 1.2 million. Okay, so let me put this subgrade direction. I will consider that my soil is a clay with sand. Okay, no, sorry, well compacted sand, very well compacted sand. Okay, very well compacted sand. So I will use well compacted sand. So it should be, okay, 1.2 million. Let me check again. No, 0.15 million. 0.15 million. So this is 1.15 million. So you need to reduce this soil. Okay, I just click OK and OK here. Here is we have another limitations when we draw our footing. Then we need to check that limitation. Okay, this is about the settlement limitations. So for making this raft footing or mat footing, I need to choose these dimensions. I will keep 1 meter of projection from these columns or load points or corners. I just go draw points. I will choose 1 meter, 1 meter. I will click here 1 meter right and 1 meter left. Both are positives, so it lies one coordinate. Okay, make one negative x and it will project left side, and make both negative, it will be left side. Make one negative, one positive, make it positive here. So these are our four points we have drawn, and just close these points. Just close these points. Very simple. It's very simple. You need to just learn the concepts. It's very simple. So let's me draw the slab or mat, because this is the property of slab. Click here and draw. Here is your name, slab. So So we have defined our points here. So from these points we will draw the mat footing here. So I click here mat footing. This is property slab not opening. This will be the mat which I have defined, and this straight line. Okay, let me click here, click here, click this point, click this point, and click this point. So it seems little bit not a rectangle. So let me redefine this point again, and I will modify my slab. Just enter. So I click here the point, I go the define, and I will draw point. I will choose -1, no, -1 here, x. I click here this point. So you can see that this was some mistake from, so the point was not right. So let me select this one again, and again let me select this one and draw this one. So edit. So this is the reshape. From draw reshape object and select this one, and reshape it. Just click here and drag here. Select here, no. Select this point, no. Yes. This is select from drag here. Reshape, draw reshape object. So we have done the reshape object. Let me delete this dimension line here. So this is our raft footing area. So now we need to define the soil property to this mat footing. Select here and assign support data soil properties. Soil 1 we have already defined, called is okay. Now this soil properties are already defined to this uh, mat. So let me go and show in 3D. Okay, so this mat we have already defined. So again we will go and we will make the load combinations d1 ds. So modify, let's check, and this is already exported from ETF. So I will keep as it is this modification, and I will go the define load case. So this is load case is okay. So let's go to the XY, and we need to make the steps. Okay, so go edit and slab design steps. So global XY fix auto. Okay, and next direction I will keep is okay. So I will keep okay. So in next direction this was defined. Now let me go and do the same process for the Y direction. Add steps in Y direction and change the step into V. Okay, so we have middle strip, column strip. So we have done for the stripping also. So let's go and run the analysis. We have done almost everything. We can revisit if something is missing and result are not appropriate. So let's go and run the analysis. I will save as mat footing, mat. Just I will mat. Okay. So these are our point loads on these corners. This is only dead load. So let me check another load combination. This is we have load pattern names SDL above. Okay. So these are the display deform shape load combination ST1 apply. So these are the, you can see here is our uh, minus 0.27. It means that our here is the settlement is 8.284. Okay, we can check for other combinations also, and here you can see is minimum settlement because our load is concentrated here, so it means settlement is maximum here. So this is about the settlement. So we can check the settlement, permissible settlement by using this data. So I will choose the data here from permissible settlement. Here is sand is 50 millimeter and isolate for raft footing, and for the raft footing clay is 85 to 100 mm. So these are the permissibles. It depends on your codes, which code you are using. So a permissible settlement, if your permissible settlement is not is more than the is less than the you are demanded and you are on your analysis, so you can increase the size, you can increase the size of your raft, or you can go with piles, or you can uh, increase the bearing capacity of your soil. So this is the almost the topics of geotech, so you can go through the geotech. My main purpose is to how to use these results with the practical designing, and this you can correlate your results. So this is apply and okay, just close it and go for the detailing setting. This detailing setting we already for done. Sorry, we have done for the slabs, so I will not go again this one. You can go through the playlist for more detail. So I just today run the analysis. Okay, so this is we have run the drafting, we have done the drafting, we have run the detailing. So these are our detailing uh, drawings. So just go to the detailing and check your, we have sections and display show slab. Okay, here you can check these are strip method, so everything is defined and checked in the slab. So these are our slab footing design. Okay, this is the requirement of the reinforcement for our footing. So we will go the typical uniform reinforcement specification below. I will apply bar number 25, top and bottom both, apply. So these are uh, further requirement of reinforcement. So I will decrease the spacing 200. I will decrease the spacing 200, apply. When I apply 200 spacing, further reinforcement is required. I will increase. Let me check which is this reinforcement required. So bottom reinforcement required. So let me increase the bottom reinforcement bar number 25, and let me decrease this 150. Apply. If you apply, you need further reinforcement required, so you go with the increased size, or you can do special treatment for this point only to increase the bottom reinforcement. Here you should not increase the bottom reinforcement for the other side. This is already the requirement is fulfilled. So let's go and increase the bar size. Apply. Now with increasing bar size, so you can go this only special case for this one, and other is okay. So let's check close and check in the reinforcement components, slab views, individual slab view, mat footing. So this is the reinforcement profile. We need to check this one. Here we can go and check how much reinforcement. Here is 8.2% we increased, as 11% over. So we should not under reinforcement. We will increase our reinforcement within the provision of the codes. So everybody knows how we apply which codes for the RCC buildings, RCC design. So you should go through the your RCC design for footings or for maximum and minimum reinforcement requirement codes. So these are the, here you can see that the green belt is more, so we have provided more reinforcement, which is not economical. We should go with less reinforcement. Okay, so go the display, F9, apply, close. Here in this portion, this is the point load line. You need to provide a special bottom reinforcement. At the middle areas, less reinforcement is required. You can check what the procedure already we have talked about. So thank you very much. If you like the video, please like it, press the like button, and also subscribe